Okay, then let's start the session today. So before starting today's session, so just giving about myself. So my name is Kumar. So actually, I'm having a total 15 years of IT experience. So about me, like I started my career as an ETL developer. So I joined as an MNC company where I worked as an ETL developer. So over there, I started working on several ETL tools in my experience. So like I worked on ETL tools, like if you know from the IT background, so if you're an experienced IT person, so you know about the data stage, which is an ETL tool, Informatica, Moody's. And also I worked on a different databases like SQL servers, Moody's, MySQL, Teradata. Uh, and also I worked in a big data, so where I worked as a big data, and also I worked as an Hadoop in an Hadoop ecosystem. So I worked on big data analytical tools like Platfora, uh, and I started on working on different roles. Like I worked as a developer, I worked as an production support, I worked as an team lead, I worked as an handling the multiple applications. So I also and also explored into the worked in the cloud era as well. So like I worked on Azure, GCP and AWS. So like using these three cloud services. So I used to develop a large amount of data pipelines. So I worked in domains like in banking domains, telecommunications domain, mm, government domains, regulatory report domains. So apart from that, I worked on reporting tools with the Cognos and Finarc, various other reporting tools like Tableau. So from the past 7 years, I'm working in a particular like cloud era, like working in AWS, GCP, and Azure. So I worked on I built large data pipelines using the GCP services. I migrated the data from one database to the GCP, from AWS to GCP, from Azure to GCP. So like migration part, and also worked with uh, Google team as well. So currently, I'm working in a project with a Google associate team. So where I closely work with the Google team and Google team members. Yeah, that's it from my side. So let's start the session. So today is about the session about GCP data engineering. So I'll just uh, give today's session about what is data engineer. So why business needs data engineer. So what is the role of a data engineer, and what is why we need to choose GCP, and what is the GCP, and what are the services we can use in the GCP. Just a brief over introduction on data engineering and GCP. So today's session will be, and also I'll explain about the course content. What are the content I'll be covering all those things. So let's start. So before going to the GCP data engineer, so let's understand what is a data engineer. So so why business and why IT needs an data engineer. So uh, so sorry. So before understanding the data engineering and all those things, we need to understand the data lifecycle. So we need to understand data lifecycle. So the first principle to learn to become a data engineer is to understand the data lifecycle. So if you work with the data, so must you must have known that the data doesn't stay in one place. So it moves from one storage to another. Like it also moves from one database to another database. It doesn't stay at one place. So to understand the data lifecycle, you need to know uh, who will consume this data, what, what data source should I use, where should I store the data, and when should the data arrive, why does the data needs to store in the place and all those things. So we need to understand the data life cycle, and we need to understand the concept like data warehouse. You need to know the concept like ETL. So based on these fundamental concepts, then you'll come to know what is the role of the data engineer. So what is a data warehouse? So I mean, if you from the IT background, or if you if you did a bachelor's degree as an IT background, we have this subject called a data warehousing subject in our IT field. So it's not a new concept. I mean, I believe you should have heard in this term in terminology. So what is a data warehouse? So so in simple term, like data warehouse is a large data where the business can analyze the data. Data. So it's like a uh, centralized repository of data. It's like a centralized repository of data where business can business can analyze and make a decision on it. So you should analyze the data where business can analyze analyze the data and make a decision on it. So the simple term I can say that, so there is a data like we have a data. If you know about the CSV data, we have the like sample customer data. It has a customer name, customer customer address and date of birth. This is a simple data. So it has a customer name information and customer address and date of birth. So there is a requirement from the business that so in the output of the business, so you should able to analyze this entire data, and it should be at least this is the input. I can say this is an input. So this is the input data. So you should analyze this data. So he wants to have an extra data, like extra column, like we can say that age. So or whenever there is an update on the customer address, it needs to be updated and all those things. So this chunk of data should be coming into this one single center repository, and the user should analyze this data and needs to understand business the data, and needs to as the and you need to make a decision on this. So imagine there is a large chunk of data is there. So I mean, I'm just saying it is simple. So the entire data should be coming to the one place and should analyze the data, and there is any redundancy of the data, you should able to do the redundancy and should be able to understand by the simpler term by the business. So this is a data warehouse. And in a simple like data warehouse, it's like a uh, the main characteristics of the data warehouses of data warehouses like data integration, historical data. Next one is the querying and reporting. So data transformation, dimensional modeling, a large of variety. So data integration, like so what data warehouse does is it colors and integrate the data with the multiple different source. So there are some input data like there is a customer data, there is an customers managers data and all those things, employees data and employees manager and employees department data. It should integrate with the different source, and it should as a and make a it should integrate into one part into the one single repository, and we need to make a and the business needs to make a analyze on the data and make a quick decision on it. And also it has an historical data. It should store the historical. So whenever there is an like an customer data, it has an address and where the customer has relocated his address. So it has to be maintained when the address is relocated and all those things. And also the coding and reporting. So at last when it is stores into the one single repository date, right? So the business, the data scientist, right here the where the data scientist comes, they will analyze the data, they'll make a decision on data based on their business requirements, and they'll coding the so it will be the data which stored in that data repository, right? Like in a large data warehouse, it should be readable by the data scientist, and it should be the uh, analyzed by the data scientists. So that's where all the there. So another thing is like data transformation. So data within the data, it will undergoes the extract, transformation, loading. So over there, it includes a process to clean the data, transform the data, enrich and it before it's stored. So this ensures the data very quality and consistency. So yeah, so this is the main characteristics of data warehouse. So the another uh, concept is an ETL. So which is nothing but extract, transform, and loading. So so in the word itself, it's there, right? It's extracting and transform and the load. So what includes the extract? So and let's take it the similar example. Like I said, we have this input file. Like for example, input CSV file. So this is the CSV file, which contains the data like customer name, customer address, and date of birth. So these data should be extracted by the echo uh, by this system. The system in the sense like this data should be extracted. So there will be a connection to this input CSV file. For example, I'm saying this. This is in the this CSV file arrives in the Linux operating system. Linux operating system. There is an tool called ETL tool called data stage. So this file should be read by this ETL tool. So so it should be established connection between this Linux operating system so that it will extract this file into the CSV file to the CSV file, and it will be extracting this CSV file. That's how the extract phase will be there, and there will be a transform over there. What transformation it will do? It will it will do the transformation. Transformation is nothing but like transformation is nothing but like a business rules. What is the at last what the business wants to see the data. So what the business user wants to see the data. So so is simple term is getting the customer name, customer address, and date of birth. So the business wants to have another column like age, or he wants to have like customer name, and its age. So over here we will be writing the transformation rules, business logics like code, everything is will be written on the transform part, and at last it will be loading into the to the database. This will be load into the database. Like at last the customer age will be loading into the database. So database like anything like Teradata, Oracle, MySQL. So it will be loading so that the business users will be accessing the table. So here in the transformation will be returning the logic, right, based on our date of birth. So we'll be returning the age, and it will be loading into the table like customer customer details. So at last in the database, the business user will be seeing like select star from uh, customer details. So we'll be loading the details, and you will see the output. So that's all. I'm just saying the simple term. So in the in real scenario, there will be a large chunk of data. So these transformation rules, these business logics will be provided by the business analyst, and over there we'll be building this data pipeline. So these are the basic fundamental concepts of like data engineer. Like, so what is I mean, so what's the difference, like what is the data engineering now? So you must have understood, right? So data engineering is a field where the data science and data management focus on the particular application of data collection and data processing. So so data engineer role is here is engineer role is he needs to develop the data pipeline. Simple terms I'm saying, he needs to develop the pipeline like end to end data. So like uh, reading the input data, writing the business business logics, business. So before that, it has to be in a the data should be defined in structure format. Mm, Uh, data should uh, he needs to write the transformation logics based on business requirement. He needs to load the data as per the business requirement, and he should integrate the data with the reporting tools. Basically, he builds the data pipeline. So end to end, like processing the data, writing the business logics data, and loading the data as per the business requirement, and so that this data which is loaded into the particular database or particular ecosystem, it should integrate with the other reporting tools. So it needs to make the entire the thing like schema definition, how the dimensions and how the if you know the dimensions and fact concepts, it needs to maintain entire the concepts. So and it needs to give the report as per the business requirement. So like it involves like there is a batch. I'm saying the ideal scenario. there is a batch data. He needs to automate the data in the batch data, and it needs to be automate the data on daily basis and write the transformation logics, and it loads into the database or any some other large amount of data like big data or in a cloud service called BigQuery. You need to make sure everything in the he needs to make sure the entire data pipeline should be built. So that's the role of the data engineer. So, I mean, I'm just covering just giving the overview of what is the data engineer role. So, in the next step, let's go to the GCP. So, what is GCP? So, it's a cloud, Google Cloud platform. So, it's like a cloud computing service which is provided by the Google. So, cloud computing service, simple terms like services provided by Google. So, earlier, so what happened? So I'm just giving a thing. So before the cloud, so how this uh, data engineer works, how the data engineer works. For example, he data engineer wants to build a data pipeline. So what all he needs to he needs to have a system where the business sends the files, right? For example, there is a files sending the business to the where the business agreed they can send the files to the Linux operating system. I'm just saying an example. So the first he needs a Linux operating system. Second, once the file arrives in the Linux operating system, what he needs to do? He needs to have a he needs to write a something code for it where the business needs. So if you want to write if there is a large amount of the data, you need to process, you need to have a ETL tools like data stage, Informatica, and like big data. So you need these tools, right? You need these tools, and you need to have a database. So, for example, the business wants to load the entire output of the data into the database. So we need to have a databases. Databases like Oracle, SQL Server, MySQL. Another thing he needs to have a reporting tool where business wants to the reporting tool. Like we can say Finar, one other reporting tool, Agnos, several retainers. I'm just saying. So he needs all those systems. I mean, he needs Linux operating system. You need to ETL tools. You need a database. You need a reporting tool. So, the business. I'm just saying. So business wants this all these applications, and he needs to maintain infrastructure of it. So in an IT field, so what happens? We just don't need I mean we just don't, so we need to have an infrastructure team for it, like maintaining like it's hard disk. So hard disk infrastructure team, admin team. Similarly, for each, like it needs an hard disk over here, it needs an infrastructure, it needs an admin team. The same goes like we need to pay the license to the data stage, Informatica, the business. Same goes with the Oracle and SQL Server and MySQL. They needs to pay the to these companies. They needs to maintain the infrastructure of it. They need to go infrastructure. They need to maintain the patches, any upgrade. They needs to have a separate team for this. Same goes with the reporting tool. They need to have, I need to have a license with the this tool owners. So whenever there is an upgrade, you need to pay this license. So, for example, there is a business requirement. Out of 24 hours, it runs only for the 10 to 12 hours. So, and we need to pay for the entire 24 hours to the data stage and Oracle and operating system and all those things, right? So lot of, and they need to have a separate hard disk, they need to have separate data centers to the IT team and all those things. This is how before the cloud is coming. So this is how it works. So it's like a cost efficiency on it. And another thing is that the company needs to bear all this infrastructure. They need to have a separate admin team, they need to have a data centers and all those things stuff. They need to have a separate teams and all those things. So what this once what is this cloud computing? So what is this cloud computing service? So this entire services like Linux operating system, like ETLs, like database, like reporting tool will be provided by this by Google. So the entire infrastructure, the entire hard disk, the entire data centers will be taken by the Google. So for example, I'm just saying in Google we can have a Linux operating system. Go to the compute engine or compute engine, just click a server, create a server for the Linux operating system. That's it. So entire services will be on the cloud, like in the network, in the cloud. You just need to create a Linux server system. Just create server for the Linux. That's it. So the IT and like the business team need not worry about what is Linux. They need to install like Linux operating system now. They need to have an hard disk. They need to have an infrastructure. So the entire patching system, the entire uh, uh, hard disk, all the data centers, or where the data stores, and entire will be taken care by the cloud computing service, like one we are discussing, like GCP. So it entire provides, it gives all the services, like it performs the ETL, it can store the large amount of the data, it have the databases, it can migrate the data from Oracle to the GCP, it provides reporting tools, it can integrate with the reporting tools. The entire thing will be given by the GCP. So that's the reason. So what's the company is doing? So the mostly they're migrating to entire to GCP or to the Azure or to the AWS, because this entire services, like entire infrastructure, is providing by Google, by the GCP. So, and another good part is that it will build the whenever we are using it. So that's a very good feature for it. So for example, there is a business requirement, it runs only for the 10 hours, the rest of the 24 hours I mean rest of the 22 12 hours there is no unit. So whenever we are using only, it will cost. But for the earlier case, they used to pay for the entire 24 hours. They need to maintain the patches, they need to think the infrastructure all. And also they can't store the large amount of the data. For example, if you go to the Oracle server and SQL server, they can't store the large amount of the data. So that's what where this GCP comes. So so we are coming to this. We are ideally developing the data pipelines using these GCP services. That's what the GCP data engineer roles not only think it as you will migrate the data from different database into the GCP. And it the another important thing I need to show you about this GCP. These are the basic services provided as a GCP. Like it has compute, storage, and big data. So we, as a data engineer, we ideally mostly work on this storage and the big data part. So where we have the cloud, big table, cloud storage, cloud SQL, cloud spanner, cloud and storing the large amount of the data. You can use the cloud BigQuery, cloud data flow, and cloud data log. So based on this, I mean, mostly ideally scenario, most of this using these services only we build the data pipelines in the GCP, and we have this artificial intelligence services like cloud vision and speech, and we have this compute engine. As I said, we can create the services using the compute engine, Kubernetes engine, and app engine, and the cloud functions. So, so and the I mean, so these are the course I will be covering today. So in my course, mostly what will be there is like as a data engineering perspective. So like mostly we like a 30% theoretical and 70% lab. So I'll be covering the ideally business scenario. What are the business scenarios will be we will be data building the data pipelines like we have the BigQuery. So BigQuery is one of the important services in the GCP. So we'll be discussing about what is BigQuery and about queries and functions. I mean, writing queries and loading data, exporting the data from BigQuery. There is an important concept like uh, nested and repeated fields, and covering the business scenarios. So like in my scenarios, I mean, I'll be sharing my real IT business scenarios, how we are working with the BigQuery, how we'll extract the data from BigQuery, how we migrate the data from cloud, from MySQL database to the BigQuery. I'll just explain those ideal business scenario. We'll be covering the cloud SQL and cloud spanner service, GCS buckets, um, Google Cloud Dataproc. So Dataproc is another important Dataproc is an important service. So it's like a big data in the big data platform in the cloud. So like Hadoop, developing the Hadoop clusters, running the Dataproc jobs, like ideal business scenario, and running the Spark jobs, and how we are loading this into the BigQuery. There is a HDFS ecosystem where this the data needs to be loaded into the BigQuery. I'll be giving those scenarios, um, and integrating with the data platform in the GCP, like how we can extract the how we can connect to the HDFS ecosystem and then extract those data and dumping into the GCS buckets. And there is another data flow which is nothing but Apache Beam provided by the GCP. We call it as a data flow in GCP. So I'll be explaining the data flow concepts and ideal business scenarios, how we need to handle the stream data and batch data using the data flow. We another important service like Google Cloud Functions, Google Cloud Scheduler, PubSub, Google. This is another orchestration tool called Google Cloud Composer, which is an Airflow which is provided by the GCP, and machine learning services. And we need to know about the identity and access management service as well. So how do we need to give the roles and permissions and all those things. So another important, I mean, thing is that continuous CI/CD pipeline. So in GCP, it has also have a concept like CI/CD. So it can do the automatic deployments. As a data engineer, we should also know about this. So these are the course content of the GCP which I will be covering into the coming sessions. Yeah. So like I said, most of my sessions will be like 30% theoretical and 70% like lab thing, and I covering the covering each and every services. Not only these modules, I'll be explaining the when we explore the GCP, right? Explaining the each services, what other services we'll be using, when we need to use the compute engine, BigQuery, SQL, and also I'll be explaining the billing, and also we have the log matrices, how we can create the alerts over it. I'll be explaining and each and every services, and also the very important part is like cloud shell. How can we play with these GCP services using the cloud shell? I'll be teaching each and every part in detail. So in coming sessions, yeah. So hope my session I got a good information you. So that's it from my end. So if you have any uh, questions, you can ask in the comment session. Yeah. Bye, guys.